All right, welcome back. Tobias and I want to thank you again for spending some time with us today. And we want to continue our discussion on querying, but I'm going to use that term loosely for this module in SQL Server 2012. We've been talking about for 5 modules now the idea of querying content. We're going to kind of shift a little bit to talking a little bit about inserting and updating data and how we can kind of protect that data as we're inserting and updating that data. So we're going to look here, inserts, updates, deletes. We're going to talk about the use of defaults, constraints, and triggers. So remember, one of the big things that we want is we want to make sure that we're retrieving content, and we've talked about several modules of how we're going to do that. But we want to make sure when we're adding content that we understand that the old GJO, garbage in, garbage out. So if we don't have things like constraints and we don't have data integrity procedures in place, that when we retrieve content, it may not be valid content. So we're going to look at ways for inserting, updating, deleting content, validating that content the best we can to make sure we've got good content that's going in. So we do perform some of these tasks that we've been talking about in the previous modules. We've got good stuff coming back out, not garbage like we had talked about. So we want to avoid the garbage in, garbage out. We're going to take a look at that in this module here. What we've been talking about are DML statements. This should be DML as well. Let me see what this is. Yeah, this should be DML statements. DML statements are data manipulation statements. So querying using a select statement is a DML. This is also a DML. We're going to talk about inserts and updates and deletes. DDL are statements where we create objects or modify objects or alter objects. So this should be DML instead of DDL. But we're going to talk about DML statements, continue to talk about DML statements because a select statement is a DML as well. So let's take a look at how we get content in there. So again, one of our concerns is we want to avoid the garbage in, the garbage out. So we're going to look at ways we can do that. Now we're going to add content. This is a pretty straightforward insert into statement. We're going to insert into production.unitMeasure. If we don't know the name of the columns or we don't want to supply the name or the values in any certain orders, we supply the column names. So if we looked at the unit measure, there's name, there's unit measure code, there's modified date. If I did a select asterisk from unit measure, it's actually unit measure code, then name, and modified date. That's actually how it's stored in the content. But if we want to apply values to the columns, they don't have to be in any certain order as long as we include the column headers. And that's what we've done in the top example right here. Now another way we can add content is insert into, and so this is inserting just a basic row. And notice what we're doing here. We're adding a value in the name column called square yards, and the unit measure code is Y2. And the modified date, we're actually retrieving the system date. We could hard code a date in there, but we're actually retrieving the system date. This is adding just a single row. We can add multiple rows using a similar statement. But under values, what we're going to do is we're going to add multiple occurrences of the value. Now we're adding square feet and square inches, and we're going to use F2 and I2 for inches. So this is the squaring of those types of measurements here. So that's how we can insert some of the data. We can also use what's called an insert into the content. But now instead of supplying the values, we're going to use a select statement. So it's an insert select option. And what we're going to do, to populate this name and unit measure code and modified date, we're going to select name, unit measure code, and modified date from, we'll say, a temporary unit table that exists out there. So we're going to take the content using a select statement, and we're going to populate that into the unit measure content table, excuse me. And we don't have to grab everything because we're using a select statement. We could say we only want to insert the content from January 1st, 2008. The good news about this class is I'm going to learn to understand these timestamps in reverse order. That's my goal. So this is January 1st, 2008, and we're going to only add content that's less than that. Anything older than that, we're not going to add that content. So we still have control of what content gets added. The insert into with the execute statement, we're going to insert into these 3 columns again, but this time instead we're going to execute a store procedure, and we're going to pass it some variables, the number of rows 5 and a category ID of 1, and that's going to execute or only insert content into this table that meets the only 5 rows as long as category ID is equal to 1. So again, we're controlling what content that we're adding into the tables, and that's a big deal to make sure that we're not adding that garbage in. We can also perform a select into. Again, we're going to do a select name, unit measure code, and modified date into. So now we're taking content into a temporary table. So back on slide 2 before, I wanted to use a temporary table. I could have created the temporary table from content that's inside the unit measure table. I could do a select name and unit measure code and modified date, which are columns within the unit measure table right here. And I'm going to select them and insert them into a new table called temp UOM table. And again, I'm going to be specific about what content's ordered in there or populated in there, because I'm going to put where order date is before January 1st of 2008. So again, controlling what I'm doing when I'm adding content in there. Now, one of the things we may want to do is create what's called an identity column. An identity column allows me to create a column that I don't need to populate myself. I decide what items or what numbers I want in there. So what I do is I created an integer value. I think we've got here, yeah, we've got product ID, int, identity, and then we identify what's called the seed and the increment value. By default, it's 1 and 1. So if I don't specify this, it's 1 and 1. So the very first row I insert is going to get product ID number 1. The second row is going to get number 2. The third row is going to get number 3. In the US, whether you use Fahrenheit or Celsius, the next row is going to be number 4. It doesn't really matter. But what we can do differently here is we can say we want the seed to start at 100 instead of 1. And instead of incrementing by 1, we're going to increment by 10. First row will be 100, then 110, then 120, then 130. And then it's going to populate that information automatically for me instead of me having to supply that identity column. So it's a way for us to automatically generate a number and have that number populated for me with me defining the increment value and that seed value where I start with. Now this is set up on a table level. Another option that is the sequences option. This is new in SQL Server 2012. This allows me to create it for the database. So this is going to create sequence called invoice sequence as an integer. And here's my seed value. It start with 5. And here's my increment value, start with 5, or increment by 5, excuse me. So wherever I use this, invoice.suq, it's going to start, the first row is going to be added as 5, the next row will be 10, 15, 20, etc. And then if I want to retrieve information, like what's the last number that was used, I can select next value for dbo.invoice sequence. So if the last number used was 25, the next value would be 30. If I'm quick with math, I can do 25 or 30 minus 5 is the 25. So this would retrieve what the next value is going to be used, that's going to be populated using this sequences option, which again, new to 2012 and set up more, instead of a table level like the identity, it's set up at the database level. Now, ways for us to modify content. We might store content in SQL Server and realize, oops, I shouldn't have done it that way, or I need to change that. We have the update statement, all right? Now, we got to be careful about this. Update production.unitMeasure, set modified date equal get date. Now, if I stopped right there and just executed this statement, what have I just done? I've actually updated every row in the unit measure column, table, to set the modified date to today's date. What I need to do is specifically be more careful about is making sure we supply a where clause, where unit measure code equal M2. Now it's going to only go to that M2, the square miles row, and it's going to set the modified date to today's date because we're using the system value here function to get today's date and populate that. Again, be very cautious when you're doing update to make sure you supply a where clause unless you want every row to be updated. Very similar to that, we have another way we can modify data. It's called the merge. Now this is where I can use a merge to modify data based on any of the following conditions. Source matches the target, source has no match in a target, or when the target has no match in a source. So this is a nice way for us to be able to update content within a database.
Yeah, I thought we'd do a bit of a demo, just look at merge, and I will do somewhat of a stray thing to just show a bit of the XML functionality we have as well in the product, because it kind of fits nicely in this particular topic. So bear with me a little bit so we get a kind of an interesting example going.
We swapped out his keyboard, by the way, because the other one burnt out, so we should be good to go for a while.
So. Thank you, Brian.
You don't have carpal tunnel or anything, dude? I don't think you have time for carpal tunnel. I think your nerves don't even...
Okay, so let's say that what I want to do is I want to retrieve products in XML format, and later I want to be able to grab that XML being passed from the client and actually update a set of products, update or insert a set of products based on this XML definition. So I'll start with just simplifying the table a little bit, so it's not so complicated for me to just perform the insert, because it's so many columns in here. So I'll just grab product ID and let's say name, and that's going to be enough for me. And I'll use this into keyword. And just to be clear, earlier we had examples where the tables were called temp something. They weren't necessarily temp tables, which is something differently, or something different. So I'll just call this table just products. So I'm just stealing these two columns and putting them in this table. Now let's start by grabbing this as XML. So I want to grab all columns, or all products rather, where the name starts with an A, let's say, as a filter. Okay, good, 3 of them. And I would like this, again, returned as XML. So I'll say for XML, and the best, what you typically use is for XML path. There's for XML raw, auto, explicit, and path. But path is the more powerful one. Now, why would you like to return anything as XML? It turns out it's very practical format for interchange between systems. So if you want to pass a set from SQL Server to something else, XML is one of the good formats to use. We get a common ask if we support JSON format, which we don't do yet. Obviously, you can convert XML into JSON and the reverse on the client side. So anyway, at any rate, I'll say, okay, grab me this, and for each row, I want to generate an element called product. And I want a root element at the root called, let's say, products. So by default, for XML path, root, and let's have the asterisk in there. So now you can see I get some sort of XML document back, and this is the default structure I get. So this you can see, for every row I get one of those, and I get one of this root thing generated as per my for XML class. And you can see by default I get one element, this is called an element in XML, for each column. But I can name them a bit differently to basically change the format. So I'll call this one ID. And the @ means that I would like it to be an attribute rather than an element. And why I use these quotation marks is just because the @ has a meaning in SQL, right? So it's a delimited identifier. And I want the name just like this. Why I make everything lowercase is by definition XML is case sensitive. So for me at least it simplifies if everything is lowercase. And now the XML that I'm getting back looks like this. Okay. So you can see it's actually fairly simple to retrieve an XML document. You can do more elaborate things with subqueries and create tree structures as well, but this kind of gets you started. So now we grab the data. Now I want to look at what if I want to use this as a way to insert new data into the table or update data. So let's say we're passing this back into the server, and we actually have a data type called XML. So we'll say, okay, this, which we support implicit casting to and from string. So I pass this into the server, and let's add a new product. And I don't know what ID it's going to get because there isn't an identity in there. So let me actually just put it in. So 10,000, 100,000, Tobias. Okay, so this is a new one. And let's say we want to update these, so we'll add an exclamation mark at the end of these 3. So just seeing now I pass this string to the server, it parses it into an XML structure internally, and then I can go and query it. So now we're doing the reverse. Before I generated XML from a result set, going from tabular to XML, now I'm doing the reverse. So I'll do select star from my XML variable, and it has a few methods to it, and nodes is one of the interesting ones. So basically say, hey, go and look for this XPath expression, which is kind of like select against the from and where clause, basically against an XML structure. So basically this says, for each product found under products, give me a row back. And we'll call this xt, as the set is called xt, and it will return one column which includes the XML element, which I'll call xc, so the column. So now I can say, okay, xt.xc.value, and I can use this to go into the product element and grab things. So I'll go and say, well, I would like to grab the ID attribute, and I would like you to grab this as an integer, and I'll call this product ID. And I would also like you to go into the element and grab me the name attribute and return this as, I don't know, mvarchar 1000, let's say, as name. So let's just go ahead and execute this, and I'll go ahead and just comment out what I have above here. Okay, so again, I pass in the structure, I say, grab me each product element from products and return this. Ah, okay, nice. I can now parse this XML nicely, and now I have a set. So now, what if I could use the merge statement to actually merge this data from the XML structure into the table? So I'll say merge into products, I guess the table was called, as this is the destination, right? Yeah. Using my XML variable. And now I would have to paste this whole thing in there, but since we know about common table expressions, I could just say, well, let's call this one source, or SRC. So now I have a common table expression called SRC. So I say using SRC. So now I'm joining the table with my XML document on src.productID equals destination product ID. And then I can start using these various events that we will go through in the merge statement. So basically I can say when I think it's not matched. So if the product ID is not found in the destination, then I would like to insert, obviously. So I'll say, okay, go ahead and insert into, obviously, the destination. So I don't say anything other than the column name. So insert to product ID and name, the values destination dot product ID, or sorry, source product ID, comma source name. Okay, so when it doesn't find it, it inserts. And then when matched, I would like it to update. So update the source set, and product ID obviously can't change, so set name equal to source product ID. And obviously I have, no, that seems correct. Okay, let's see if this works. Oh, it is an identity.
Yeah,
it is an identity column. Aha, there we go. Let's just not include the product ID then. And let's not include it up in the XML either. So. And there we go.
Nice.
So now it actually added these, and we can go and select, run the select statement from the table again for the XML, to grab the XML, and I'll say like A or name like Tobias. Let's just say Tob. So we get that row as well. And now you can see that the exclamation marks are in there and Tobias was added. The final thing I wanted to show, which gets it a bit extra interesting, is let's get the correct Tobias value in there. So I got 1000. Oh, okay, cool. So ID equals 1000. Let's say I wanted to delete as well. So let's say, okay, I want to delete this AWC logo cap. How would I do this? We have something supported where you can say when not matched in source. That's very dangerous because that means if it's not in this set, then remove it. Yeah. Which obviously then would remove all other products. So what I could do instead is I can add another attribute and say, call it delete. And I'll say delete equals true. So I would like to delete this one. We'll grab that from the XML document as well and say, well, grab the delete field as a bit. And I'll call it do delete, as delete is a reserved keyword. So now I'm grabbing if it should be deleted or not, and I can just say, if it's not found, obviously we'll return null. So I'll just say, okay, if it returns null, then we'll say false, right? Do delete. And now I can say, when matched, then this. When not matched, then, when matched and do delete equals 1. Then delete, right? So I can actually have more complex expressions in the when clause rather than just say matched or not matched. Obviously, the other one has to be the opposite, right? So we should say here, well, if it's 0, then don't then update. So we'll go ahead and try and execute this. Seems to work, right? So again, not matched insert, not matched and do delete false update, or matched and do delete false update, and then matched and do delete one, then delete. And now if we query, we can see that the row was deleted.
Yes, nice.
So then you got a bit of an intro into what you can do with XML in SQL Server 2012 as well.
Very nice. Now, I mean, there are other ways that we can delete content that's probably not quite as complicated as writing. If you're not in the need for XML, we can use a delete statement. I know it's not as fun and cool as what Tobias just did, but we could just do a delete from the table. And again, very critical, just like the update clause. If you don't have a where clause, if I did a delete from production.unit measure, what am I going to delete without a where clause? What's going to be deleted? You got it, everything. So we want to be careful about that. Pretty much whenever you use an update and a delete, you're going to want to use a where clause, just because you want to avoid what I call RPEs, resume producing events. So you want to make sure you don't have to generate a new resume because you deleted 40,000 rows of really valuable information. So delete from whatever the table is, where unit measure equal, and specify the criteria that you want to meet in order for that row to be deleted. Now, you may want to delete everything from a table. Now, one way to do that is use this delete clause statement without a where clause. Another way to do this, but if you do it this way, by the way, this is logged in your transaction log. If you use the truncate table to remove all data, we're going to truncate the table. That means pretty much don't delete the table, but take all of the data out of the table. All right? And the good thing about this is not going to write every row to or there's minimal logging for the information that's being written to the transaction log. So it'll go much faster if you have 40, 50, 60, 70,000 rows in there. It'll be a little bit faster for you to be able to delete that.
Well, especially, let's say you have
a million
5
rows.
billion rows.
Yeah, a billion rows.
Definitely there will be a huge difference.
Aren't you supposed to go $5 billion? Or what? Yeah. You probably don't know that. What was that show? Awesome Pal. Yeah.
I will start referencing Swedish shows.
Yeah. All right, so we did inserts, updates, deletes with XML. Just trying to see if there's anything here. No, I think you got the cool stuff, especially with that merge, so that's good. Constraints and triggers. One of the things, so we looked at adding content and making sure that we can add content several different ways, updating the content, deleting the content. But one of the things we need to be concerned about as well is data integrity. So what we can use when we're adding content are constraints and triggers. And what they can do for us is to make sure that what we're adding is appropriate or valid. And we can also make sure that if we're adding content or updating content, that if there are other tables that need to be updated as well, we can make sure those are updated. So we can create 4 or 5 different types of constraints. We'll introduce each one of those. And we can also implement what are called triggers. So I could have an update trigger on the employee table. So on the employee table, if I update the last name there, I'm going to fire a trigger that's going to go out and also update the accounts payable table or the accounts receivable or payroll table. So anywhere that last name resides in my database, I can have it go out using a trigger and update every call that needs to be updated for that last name. So that's the idea of a DML trigger, where I'm doing data manipulation and I'm going to use triggers. Let's talk about our constraints. We have a primary key constraint. This is very, very important when you're designing your database and your rows with your tables within the database. What this does for you is it ensures that you have uniqueness on that table. Pretty much every table you're going to use in a relational database will have a primary key on it. And that primary key is going to enforce uniqueness. Now, one of the chats that came in earlier is like, well, does a primary key have to be a composite key, or can a composite key be a primary key? A composite key is a key that contains 2 or more columns. So absolutely a primary key can be a composite key. A foreign key can be a composite key. A unique constraint could be a composite key. So a composite key is just multiple columns are required to make that unique. Let's say, for instance, I have a driver's license. My driver's license number is 1234, and I'm from Arizona. Now, Tobias also has a driver's license, and he's 1234, and he's from Washington. Well, if we put those in the same table, I can't enforce uniqueness, because if we have just the primary key on the driver's license number for 1234, the first one in is going to win. The second one says, sorry, we already have a 1234, we can't play. So
and I'll be first in.
You don't get a driver's license.
No, I'll be first.
So what we'll do is we'll actually create a composite primary key. So we're going to take 1, 2, 3, 4, and we're going to concatenate on WA for Washington. And we're going to take my 1, 2, 3, 4, concatenate AZ. We'll make that a composite primary key. Now they're unique. Now they're going to use the columns together to enforce the uniqueness. Now we can work together. Now we can both be in that database. AZ is alphabetical before WA unless they do it descending order. So I should win anyway, but that's a side note. First one in wins. So what we do is we can add a primary key to a table. It can be composite. It enforces uniqueness for us. And pretty much most tables are going to have that primary key to enforce uniqueness for the values that are stored or the rows that are stored in that database or in that table. Now, in addition to that, we have what's called a foreign key. A foreign key can also be a composite key. And it's a combination of one or more columns that's going to allow us to reference that primary key. Okay, so we look at, for instance, if we come down here, this is adding one here, alter a table, we're adding a constraint called a foreign key. I like to use the prefix of the type of key at the beginning. So we have primary key, we have foreign key, we have a couple more coming up. But I like to put that at the beginning so I know what type of key I'm working with. It's a foreign key. It's going to reference this table called sales reason, and it's going to reference the column over there called sales reason ID. And we're also going to talk about what happens if we try to delete that, what happens if we try to update that. We want to cascade that delete or that update. All right, so we want to make sure that that delete takes place. If it does take place, it gets cascaded. So alter table or foreign key is used to reference normally a primary key. It could be a unique constraint, which we're going to introduce next on another table. So if I'm going in, I'm adding a new product, and one of the items or in the product is category. Well, category information is not going to be stored in that table. It's going to be stored in another table called categories. Well, over in that second table called categories, I'm going to have a primary key and category ID. Well, I'm going to have a foreign key in the products table that references that primary key in that categories table. And just to make sure that I'm adding valid content, it's going to reference to make sure, is there a category over there called Fruit Loops or something? I have no idea where I got with Fruit Loops, but we'll go with that one. So we'll reference that to make sure it's valid data that we're adding. Now, I can only have one primary key per table. But there may be other columns in a table that I want to enforce uniqueness on. So what I can do is use a unique constraint. A unique constraint allows me to enforce uniqueness on columns other than the primary key. So we're already going to enforce uniqueness with the state code and the driver's license. Maybe we want to make sure if Social Security number is going to be in there, we want to make sure the Social Security number, because that should also be unique. But my primary key has already been consumed with the driver's license and the state code. We could create a Social Security, a unique constraint on that Social Security column to enforce the uniqueness on that column. So unique constraints are used to enforce uniqueness on columns within a table. If your primary key has already enforced uniqueness on other tables or other columns within that table. We can also introduce another type of constraint called a check constraint. This enforces the type of content or the values that are being added. This here is an example of altering a table called new table. We're adding a column called zip code. It's an integer value with a null. We're going to create a constraint on there called check zip code. And what we're going to do is we're going to set this up to check the zip code. So when someone enters in the 05468 or whatever the zip code is, it's going to make sure that no one enters 0546P. Because it's going to make sure, it can't go out and say, all right, is this a valid zip code without checking against everything in the country. But it can make sure no one that slips in accidentally, puts in an alpha character or some type of symbol.
And it better be an American zip code.
And it better be an American zip code if we're going to be doing that. Exactly, definitely.
And probably it shouldn't be an integer. It probably should be some varchar. And
varchar, yeah, because nowadays you have the dash and the three or four other characters.
Since you're using like, and like you use on strings, so.
Oh, gotcha, exactly, yeah. So this would enforce that the type of data or the values being added, make sure that there's not adding any type of inappropriate content here. The last type of constraint that we're going to talk about.
Do you have examples of inappropriate content?
I just said like 0546P, that'd be inappropriate for this column.
I see.
Just for this column.
It sounds really inappropriate.
It does. Well, you jumped all over that one like drooling a baby. So the next and the last constraint we're going to talk about is a default constraint. If there are values, and I'm probably going to get picked on by this because I'm not from Sweden. So alter table, we're going to add a default constraint. The country region code by default is going to be USA. All right.
Is that actually the?
I'll
I
pause
thought
for
it
you.
was US. That's the region code for the US.
It could be. I thought you wanted a reason to say, why does it have to be U.S.? Why can't it be Sweden? What's the Sweden's code?
SE.
SE? Okay. So if we could add US or SE as the default. I forgot I was working with him today. I would have made this SE to make it safe. But so instead of me having to supply when I'm doing an insert, instead of me having to supply the country code, it would by default, if I don't supply SE, for instance, it would by default populate that with USA. So it just makes it a little bit easier when we're adding content into a table. All right, so those are the 5 different types of constraints. They're used for enforcing the type of data being added. We're trying to make sure the content's being added is not garbage.
And we're enforcing it's USA.
And we're enforcing it's USA.
USA.
And by the way, we're going to make that table, that column, so it can't be overridden. It has to be USA or SE. All right. So those are the idea of constraints that we can use when we're inserting or updating content. The other idea that we want to look at are DML triggers. And a trigger, again, is be a way for us. It could be as simple as, hey, I'm going to go in there and create a trigger on the customer table. After someone does an insert or an update, I just want to send a message. I want to raise an error, it pops up, or I can use an XP send mail. And I can send an email to the manager and say, hey, a new customer's been added to this table. We could use it for an XML, a trigger for that. We could use a trigger for making sure the data stays consistent. And so we go in and we have a trigger on the last name column of the employee table. And that trigger is if there's an update on that column in that table, I want to trigger off so it goes out to accounts payable or it goes off to payroll. It also changes the last name in that table. And it goes to any other table that contains the last name. So you can also have a trigger that's assigned to one table that will trip or fire, and that will cause an update to take place on any other tables.
And there are a few things to kind of mention here as well. One thing I just want to mention, we'll get into it a bit later in the class, but you probably want to use the throw statement, which is new in SQL Server 2012, rather than the raise roar statement that we have down here. We'll talk a bit more about that later. But the other thing that's worth noting about triggers is the most common uses for triggers is really, one is just like Brian mentioned, to validate some sort of more complex integrity that you can't figure out with check, constraints, foreign keys, and so on, which is typically a good idea. And obviously, the more triggers you add, the more complexity you have, and there can be performance implications. The other thing that is also very common is to update denormalized data. So you have things normalized first nicely, and there are no duplicates anywhere. But then a common thing when you get into performance issues is, maybe I'll have this column here as well, and then I don't need to draw in these 6 tables to get this result set. And then it's fairly common to use triggers to go and actually update this other column when things happen. And that can get you into trouble if there's a lot of updates or inserts or whatever you're triggering on. So it's worth considering, does it always have to be absolutely up to date? If the answer is no, you're probably better off having something like a job that runs on some schedule and updates these changes.
All right, good information. The last piece we want to look at is the output clause, which is used to return information from any type of expression or whenever we're performing an insert, update, or delete. Here's an example of how we would create that. Notice in here we got delete sales shopping cart item output deleted dot asterisk. That output deleted dot asterisk specifies that all columns in the deleted rows are going to be returned to the application that called that delete. So in this case here, it might be just query editor that's calling that delete. And what we'll do is we'll verify in the rows that are matched with the where clause have been deleted. We'll go back afterwards. So we're going to delete sales.shopping cart item output deleted dot asterisk, where shopping cart ID equal 20621, and then we'll verify that that item was deleted.
Brian, can I show a demo?
I would love for you to show them a demo.
Oh, thank you. So actually this output clause
Is this
also...
be in Swedish or English?
Good Swedish. Så den här output-klausulen är jättepraktisk, för den kan man ha... let's stay with the English.
All right, thanks.
So the update or this output clause is super useful. It falls into a bit of the same bucket as these window functions that are kind of magical. This is not probably as high of a bar to get into. It's just fairly easy to use, but it's super, super useful. So just the common example is really I update, let's just say production, the product table, and I want to set the name column into uppercase, let's say. So I'll just say upper name. And after I do this, I want to go and do something else with these particular products. You can easily get into a problem here. Let's say I have a where clause here and say where list price is greater than 10, right? And let's say this is a transaction, and we'll get into transactions later, but let's say I update first. And now after, I want to go and do something else with exactly these products, right, that I updated. So first we increase the price, and then we'll go and do some other things with other tables related to these products. A problem is that if I just use the same where clause, if someone else inserted rows after my update that matched the where clause, right, where list price is greater than 10, my update may affect 10 rows. Someone else insert the 11th row, so the next statement that goes and does something updates now or manages 11 rows. Mm-hmm. Okay, that's called inconsistent analysis, and you need to have a different type of locking in place to protect yourself against that. But the update clause or the output clause can really help you here. So what I can do is, or that's called phantom row. Sorry, not inconsistent analysis. So I can say, hey, output the product ID of all of these rows, and you can say into like a table variable or something. But let's just do this. Oh. Sorry, and output inserted.product ID. So in an update, inserted will refer to the new value, and obviously I didn't change product ID, and deleted will refer to the old value. So if I do this, now I can see, 291 rows returned, and those are exactly the products that I updated. So what I can now do is, obviously on the client side, if I just return this, I know I updated exactly these products. Mm-hmm. The other thing I could do is, I can say, okay, I'll have a table variable that contains this product ID column, and I can now go and do into that product ID or the temp table variable. And now exactly these product IDs are in there, so then later in your queries you can now start joining with this table variable, and it will contain exactly those columns that you, or those rows that you updated. So now you don't need to worry about problems such as phantom rows, and you don't need to increase the locking, the transaction isolation level, which could basically decrease your chances of having good concurrency.
All right, outstanding. So we're going to wrap this up. We walked through some of the DML statements, unlike what it said in the front. It's DML statements, and these included the insert, updates, deletes. We showed you different ways for inserting content, specifically with the insert into statement, the select statement, the exec statement. We talked about select into. We also told you how we could use update or merge. We got a demo on how to use the merge for updating content. Different ways for us to remove data include the delete statement or the truncate table statement, which can be used to delete the content or either a row, or if you want to delete everything in a table, just use a delete without a where clause, or use the truncate table option. We talked about the identity property versus the sequence property. Sequence is new in 2010 or 12, and what this will do for us is it's more of a database level sequence or column that I can use, and I still have the seed and increment values I can set versus the identity property that's been around for a while, and that's more of a table level. But again, I can supply the seed and increment value for that. We talked about the 5 different types of constraints that we can use: the primary key, the foreign key, the unique, the check, and the default constraint. And then we also talked about the use of DML triggers. And as Tobias pointed out, we specified the use of raise error. Later on, we're going to see the throw. We're going to talk about how that would be a little bit more beneficial. So let's take about a 10-minute stretch, and we're going to come back here. We'll continue our discussion into the next module, where we're going to talk about some programming elements, some error handling, and that's where we're going to introduce items like the throw and catch. So we'll see you back here in about 10 minutes. Enjoy the break.